13F, solving logarithmic equations. I don't always have to have a log in my equation to know that I have to use it in order to solve it. Previously, what we've done is we've looked at the two sides, so say we've got example A there. We've got the two sides, 2 to the power of x is equal to 12, and we've thought about how can I change 12 so that the base matches. Unfortunately, that doesn't work all the time, and this is one of those times here. So what we're going to do is use our rule, a to the power of y is equal to x, and how that can change into log of a, x is equal to y. So same idea here. In this case, a is 2, y is x, and the 12 is x. So there's a few different x's and y's going around, but the idea is that that is each of these variables here. So what that can be transferred into, the base always stays, the answer goes on the inside, and then the power is on the outside. Now log 2 of 12 is actually a number, so we can't know what it is just by thinking about it or trying to calculate it in our head. You'd actually need to use a calculator, but when an exam or test asks you to solve this using exact values, you just leave your answer as log 2 12 because that is an actual number. Let's try part B. Again, I cannot change 17 to be a base of 3. So to get 3 onto the other side, I'm going to take the log. So that'll be log 3 of 17 equals 2x plus 1. So it leaves over this power. Now I just need to solve for x. I'm going to take the 1 over and then divide everything by 2. To write that neatly, I can write it as a half log 317 and minus 1 half. Again, this is a number that we can work out using a calculator. For part C, I can just simply take the log of 0.5, but we want to avoid doing logs of decimals. So I will rewrite these firstly as fractions. So a half can be rewritten as 1 on 2, all to the power of x, and this can be rewritten as 2 on 5. Now 1 half can be rewritten as 2 to the power of negative 1. So now when I take the log, so when I'm taking it to the other side, I'm just going to continue up here, that will end up being negative x, and that will be log 2 of 2/5. And then to get that negative by itself, I'm just going to divide both sides by negative 1. This is a more appropriate answer than we had before. What we can do is we can even get rid of that negative by taking it as a power. And remembering that when I put a fraction to a negative power, all I have to do is flip it over. So I get x is greater than log 2 of 5 on 2. Now we're going to be asked to sketch the graph of an exponential. This time, what we can do is actually find the x-intercepts. If you remember the exercise that we did 13C, we couldn't find one of the x-intercepts because it required the use of logs. This time we know how to use them. So this is an exponential graph. It's got a base of 3, it's got a dilation of 2, and most importantly, it's got an asymptote at y is equal to negative 4. So the whole graph has been dropped by negative 4. There has been no reflection, so I know my graph is going to look like this. Let's start by finding our intercept. So when x is equal to 0, let's find our y-intercept. That'll be 2 times 3 to the power of 0 minus 4. 3 to the power of 0 is just 1, so 2 minus 4 is negative 2. And then in order to find my x-intercept, I'm going to make y equal to 0. I will take the negative 4 to the other side. That will make it positive 4. I will then divide both sides by 2. And then you can see that I can't rewrite 2 as a base of 3. So what I have to do is I have to take the log of the other side. So that'll be log 3 of 2. Now, although I don't know what that value actually is, I know that my graph needs to pass through this point. So wherever it happens to intersect on the x-axis is going to be my x-intercept.